So you might be sick of it being freezing cold at home. It might be 15 degrees inside in winter. Or perhaps you're sick of the air conditioning blowing hot air, drying you out, going on and off, those wild temperature fluctuations. Or maybe you've been to a friend's house, or you've been to somewhere in Europe where they have a radiator heating system and it just feels totally natural and comfortable inside. So today I'm going to tell you a little bit about the pros and cons of radiator heating systems, how they work, the different options, and a few mistakes to look out for, and then what to do if you're interested in a radiator system for your house. So I'm Phil from Euroheat, and Euroheat has been designing and installing radiator and other hydronic heating and cooling systems for 32 years. And what that means is that we've seen all of the ups and downs, the mistakes, the systems that work really well, and we know how to make sure that you get a quality radiator heating system that's going to be comfortable and energy efficient too. So let me explain how radiators work. To start off with, we'll go through the real basics and then we'll get into some of the more interesting stuff. So a radiator system has a heat source, which might be a condensing boiler which uses gas, or a hydronic heat pump, which uses electricity and otherwise harvests energy, usually from the air or maybe from the ground. And so it produces this heat, and that heat is put into some water, and in this closed circuit where the heat pump, let's use in this example, heats up water and it sends it through insulated pipes to, let's say, radiators like you can see behind me on the wall here. And those radiators then heat up and they radiate heat into the room. Now, not 100% of the output of the radiator is radiation or infrared heat. It's sort of around 50 to 60%. It really depends on the water temperature that's going through. But let's say roughly 50 to 60%. Then another, say, 30 to 40% is convection. So that's where the air is heated up. And so cool air, which hangs around the floor normally, will get picked up, will touch the radiator inside the convector fins, and it'll heat up and it'll rise up. And this, what happens is a natural circulation of warm air. So that sort of helps heat the room too, but mainly it's that radiation. Now there's a little bit left over, you might have noticed in my percentages there, and that's because some of the heat actually is lost through the brackets, which go either attached to the wall or the floor, and they heat up as well, and that energy passes into, let's say, the wall or the floor. But all of the energy we want, basically making it to the radiator, and if it gets to the radiator and we haven't lost much on the way, that's great. So why are radiator systems so popular, or the standard in Europe, even though a lot of houses have hydronic floor heating, which is fantastic and is probably, to be honest, a little bit of a better solution than radiators in terms of energy efficiency and aesthetics, because it's invisible, but it's not always possible in buildings, especially an old one like this. So this building, I believe, was built in 1895, and there's beautiful Jarrah timber floorboards here, which are as old as the house. And so putting floor heating here isn't really practical and doesn't fit with the owner's aesthetic desires. So radiators are therefore the next best thing. And radiators can create the perfect comfort here in not only in winter, but also in autumn and in spring, where there are the cold nights and the cold mornings. So why are radiators so good at creating a comfortable environment in your house? So if we think back to the percentages I was just talking about, that the majority of the heat is given out by radiation, not by convection and conduction. They're the minority. Where if you have an air conditioning system, the vast majority of that heat is through convection. So it's pushing the air, it's pushing hot air down into the room and trying to displace the cold air that's down the bottom. Mix the air in the room so it can sort of get some of that cold air, heat it up, and heat the rest of the room. But what happens is that The room, sure, the air heats up a little bit, or it might heat up to 25 degrees. And this is the strange thing about air conditioning, which you probably would have experienced, where, you know, it says 25 or even 28 degrees on the room temperature controller, but you're still cold. And the reason is because the air temperature is high, for example, but all of the surfaces in the room or in the house are cold. So they might be at 15 or 13 degrees. And what that means is your body, sure, the air is warm in the room, and when it touches your skin, you can sort of, you can feel it, but your body is still emitting heat and is in a sort of a net loss situation where the walls and the floor and everything are absorbing the heat radiation that you're giving off. So how do radiators, you know, how are they different? Well, because they radiate the heat, they actually, your body absorbs that heat. So instead of being with the warm air, with aircon, with the radiators, if you walk past or if you're in the direct line of sight of the radiator, you're no longer in net heat loss, you're in net heat gain, because the radiator is giving out heat and your body is absorbing that. So it's sort of like standing in the sun on a sunny winter's day where, sure, the air is cold, but you feel warm because the sun is heating you up. And that's the beauty about these systems, where you can actually set, so in this particular house, the owner sets the heating to 19 degrees. Now you might think that's cold, but it's perfectly warm. You walk in here right now, the heating system's on, it's perfect. Like I even feel maybe a little bit too warm. I'm wearing jeans and I'm stressing out a little bit because I'm on video, but you don't have to pump the temperature up. What happens is the radiator radiates the heat, and the floor and the walls and the furniture and everything absorbs this heat, and they become secondary emitters of the heat. So everything then is radiating at you sort of evenly around the room, and your body just loves that. It feels super comfortable in that situation. Now, the other thing that, the issue with air conditioning heating is, and I'm not ragging on air conditioning is fantastic, like you need it for cooling. It's really difficult to cool without air conditioning, so it's required. But it doesn't give you the comfort level or the efficiency, which we'll get into, with heating. So the other thing that the aircon does is it stirs up a lot of the air. It has to push the air down at a high velocity to try and displace the air down the bottom, swells it all around. And so that throws around all the dust. So, you know, it's pretty bad for asthmatics, for example. But it also, because it's going past your skin, you feel like dry, you know, and your eyes might dry out, maybe even your throat dries out a little bit. So you feel uncomfortable. Now, with the radiator, as we know, the majority of the heat is given off as radiation, but some of it is given off as convection. I mentioned before, it's around 30 to 40%. But what's the difference? If that's giving off heat by convection too, how is it different to the aircon? Well, the aircon has a fan in there and it's spitting it out really fast, so it disturbs the cold air which hangs around at the base of the room. Now the radiator doesn't have any moving parts. It's totally still, and that's why it's silent, and it naturally heats up the air, and it just does that at a really slow, gentle pace. So you don't get the same sort of dust movement and the feeling. You don't get any of those unpleasant feelings you get with the air conditioning heating. So the fact that radiators don't have any moving parts is actually one of the keys to why they're energy efficient compared to, say, air conditioning. So because with air conditioning you need to have a fan which is spinning really fast to push the air down, that consumes a bit of energy, whereas this just does it naturally, and that's why radiators are generally at a low level. These radiators, a little note, are pretty high, and you might be able to actually see on the copper pipes, the pipes had to be extended, and the reason is here the owner planned, when they were doing the renovation, planned to have smaller skirting boards around, and so the pipes were, you know, made to basically be the perfect length. Then they changed their mind about the skirting boards, so then the pipes had to be extended, and the radiator sits high up. Now it still works perfectly. They're at about, just looking at it, about 200 to 250 millimeters above the floor level, but usually we would place the radiators at about 100 to 150 millimeters above the floor level. And that just means it does a really good job of naturally taking in that cooler air, which is hanging around the floor, which might be at, let's say, 19 degrees. And then it picks that up, heats it, and sends it on its way to heat the rest of the room naturally and gently. The other reason why radiators are really energy efficient are because most of the heat is coming out as radiation. We don't actually need to heat anything like the air for you to feel comfortable. Now, you know, as we have discussed, some of the air does get heated, comes like through convection, but we can't do anything about that, unfortunately, unless there was a vacuum, you know, in there, and we could separate basically the heated surface from the air in the room with a vacuum, sort of like double glazing, then we are always going to get some sort of natural convection. But the radiation doesn't need this medium like air or anything like that. So the radiation just gets sent out and heats everything in its path. And that means that because we're not heating all of the air, we don't have losses high in the room. So with air conditioning, because it's just heating the room air, it heats up the air, the hot air stays underneath the ceiling, and then it all just basically escapes. And a lot of houses, even though they might be new, the insulation isn't installed properly, and there's gaps, and you know, there's bits that have been moved by some tradie that's gone in there to, you know, check something or change something, and then there's this bits of spots with this massive heat loss. So because we're sending it out with radiation, then we avoid a lot of those heat losses. Now you might be thinking, well, that's great, Phil, I can just get a radiator, an oil-filled radiator from the local retailer, and that's only going to cost a couple of $100, and I can just plug it in. But while that will work, a lot of those radiators are actually, say the oil-filled ones, they have a lot of surface area, but the way that they're designed, you don't actually get the benefit of that. You can get now electric panels, which I have seen, which do cost a few hundred, or you know, let's say up to $1,000, and they just plug directly into the electricity and heat up that way. But they have an efficiency challenge, let's call it a challenge. And the reason is, it's sort of like a kettle where, or let's use an electric hot water heater as an example. If you have an electric hot water unit in your house, you've got a heating element in there, and if you put in 1 kilowatt of electricity, you'll get about 0.99 kilowatts of heat out of it. But if you get a heat pump hot water unit, well, you put in 1 kilowatt of electricity and you can get, let's say, 4 kilowatts of heat out of it. Now, this applies with the radiators too. If you get an electric radiator, where you just plug it in, so you'll put in 1 kilowatt of electricity, you get 0.99 kilowatts of heat out. That's 99% efficiency. With our radiators, if we put in, and we have a heat pump, if we put in 1 kilowatt of electricity, we usually design our systems so that they have, well actually at this house, I had a look at the data, and the COP is 4.5. And that means that for every kilowatt that goes in, you're getting 4.5 kilowatts of heat out. So 450% efficiency compared to 99% efficiency. So that is another reason why they're very energy efficient. So you can heat basically a whole house for the same amount of electricity that you need to heat one room, let's say with one of these portable or one of these electric panel heaters. So heat pumps are great, but they need space and they cost a pretty penny to put in. I'm just going to tell you now, they're not exactly the cheapest thing. But if you're planning to be in your house for, let's say, 10 to 20 years, it's a worthwhile investment because we can calculate the payback period for you, and you can see that it will pay off over time. Now, sometimes, you know, for either budgetary reasons, for space reasons, or you know, the variety of factors, a heat pump isn't suitable for a project. So the other way is a gas boiler. Now, gas boilers have been used for a really long time. These days, we only install, if we do install a gas boiler, we install a condensing gas boiler. And what that means is it's a more advanced type of boiler that basically converts 100% of the gas into, it burns to create the heat, and it captures, 100% of that heat. Whereas the old classic boilers would only capture, let's say, 80% of that heat created by the combustion, therefore 20% of it would just get blown out. So just for a little bit extra, you can get full efficiency. And I think the last time we did a payback period analysis on that, it was about 2 years or 2.5 years for the extra cost of the condensing boiler to pay for itself. So they're the two main energy or heat sources for radiators. Are there other options? Look, there are. People ask about solar hot water. I don't recommend that because it is expensive to put in, and usually when you need the heat, that's when it's not producing heat. So it produces a lot of heat in summer, but in winter, in the early mornings or in the evenings, it's not making heat. Even though it might create a bit of heat during the day and store that, it's not enough for the radiator system. You need to have a dedicated heat pump because your heating load might be 10 kilowatts, 15 kilowatts, or over 20 kilowatts. Some houses have 50, like bigger houses, have like a 50 kilowatt heat load. And say a solar hot water heater might only produce a couple of kilowatts a day. So I wouldn't worry about that. It's better to put that money into a solar power system, like solar PV, and then use a heat pump. And why we recommend that is, sure, if it's like, let's say in Perth, it's a sunny winter's day, so it's cold, but the sun's still shining, we're producing electricity. Beautiful, we can use that and we can preheat the house automatically during the day to capitalize on that. In summer, perfect. When the sun's shining, you can use the same PV, the solar system, for your air conditioning. So it's great. And then if you're not using it, sure, like you have to use it or it gets sent back, but you can use it for your appliances, etc., etc. It's very usable. Whereas the solar hot water, you're basically stuck with a little bit of hot water and it's not that useful. You can do all sorts of other things like wood-fired boilers, and there's a myriad of ways to heat the water up, but they're usually costly. Even though they're a good idea, someone might say, oh, I've got a lot of wood on my farm or something like that. You know, by the time we set it up, it's costly. You might as well just put a heat pump in and then it's automatic. You don't have to worry about it. You don't have to feed the wood into the wood burner or, you know, whatever it may be. So look, one of the key elements is that the system should be automatic and maintenance, or really low maintenance, right? Because you don't want the hassle of dealing with it. So one way, well, a couple of points to make them, automated and hassle-free. You need a good control system. So you need at least one thermostat controller in the house, somewhere in the heated area, which measures the temperature, and then it decides whether the system should come on and off. You can have simple ones, or you can have more sophisticated ones that, say, work together with the solar power system, but they're details that can be resolved later. But the key to that is that it monitors the temperature and then it automatically turns the system on and off to keep your house warm rather. Another important point with the maintenance is there should be automatic air bleeders in the system, which get rid of little pockets of air, which are the enemy of hydronic systems, because they stop water from flowing to the radiators or through the heat pump. And there should be an automatic fill valve, which when it pushes these little air bubbles out, which are there at the start, and over the first year or two they get pushed out, and then there's no more air bubbles. But this automatic fill valve just automatically lets a little bit of water in to make up for the lost pressure from the air escaping. And we need to keep the system pressurized so that it works, so it can pump around effectively. And then another point, which a lot of people don't do, is you should put some water treatment in the system water, because a lot of the components in hydronic heating systems are actually just steel. So the pumps that are used, the expansion vessels, or even the radiators like this, most of the time they're just steel, even though they're nice and white and powder coated on the outside. Inside they're just mild steel. And that's fine. You might think, oh, that's dodgy to rust. But if there's no air in the system and you put this water treatment in there, they will have a lifespan of 30 years or more. These ones are actually guaranteed, that you can see behind me, for 30 years. So if they're treated right, they will last, they might even outlast us. So I keep getting sidetracked and I keep babbling on about efficiency and this and how to avoid some mistakes. I'll sort of circle back and we'll go into the different types of radiators. So the ones that you can see here on the wall are just your classic standard radiator panels. And look, some people don't like the look of them. I personally don't mind them, but it's probably my European background. They just look sort of normal to me, and they seem to sort of just blend in after a while. You can get all sorts of fancy radiators, ones that look amazing, really modern, or you can get like really old looking ones like cast iron. You can get ones made of aluminium and stainless steel and all sorts of materials. And sometimes we do put those in. Probably the second most popular radiator we put in radiator type we put in are the cast iron in sort of houses like this, the Federation or the Heritage houses. But these you just can't beat because they are produced on a mass scale. They're in almost every house in Europe. They're in Canada, they're in a lot of colder Asian countries. So they are just pumped out of the factories, and because of the economies of scale, the price of them is great. And so to install, say instead of this, a cast iron radiator might cost double. So you have to be really committed to the aesthetics to go for one of the special radiators. So these are usually what we recommend. We do offer options for the different styles, but most of the time it's these. We already talked about the different options for the heat source, so we recommend usually either a heat pump or a hydronic boiler. And then apart from that, there's not that many options. You need some controls, and then you need to have insulated piping. Now, often we see when people call us and they say, oh, you know, so-and-so's installed a radiator system in our house, but it's costing an arm and a leg to run, or, you know, it's not heating the rooms up properly. So the common issue is that, first of all, they don't insulate the pipes. And so what happens is, you know, they've got these hot water pipes, there's a flow and return pipe to each radiator. If they don't insulate it, that's just giving off heat, and it loses heat on the way, and it might lose 20%, even 50% of its heat potentially on the way. And you don't know where that heat is going, it's just being lost. It might be in your roof space or under the floor or somewhere else. So you need to make sure it's insulated, and insulated, obviously the thicker the insulation, the better. And you want everything to be insulated. A lot of the time we see, you know, sure, people might insulate the pipes, but then there's the valves and elbows and other fittings, and they're not insulated, but they all lose heat as well. So make sure that everything's insulated. We often see that the radiators are, say, undersized because people are trying to, you know, get in the lowest quote or save some money, cut some corners, so they put in a small radiator. And what that means is they have to up the temperature of the water that the heat source is producing. Now for a gas boiler, it's not that big of a problem. Whether a gas boiler is producing 35, 45 degree water, or it's producing, say, 55, 65 degree water, or even higher, 75, doesn't make that much of a difference. There is a marginal efficiency drop, but it's not huge. But with a heat pump, this is massive. With a heat pump, ideally, you want to be producing the lowest temperature water that you can. And so that means that, sure, there are heat pumps that can produce 75 degree water, but the penalty you pay there is that the efficiency isn't now 450%, it might be 200% or less. So you're not getting the return, the financial return that you should see. So we design traditionally our systems with heat pumps for, let's say, 45 degree water, but we also have a little advanced trick up our sleeves. And what happens is we monitor the temperature not only inside the house, but also outside. And then we have a program which exactly calculates the optimum water temperature to send to each radiator. And what that means is we can maintain the comfort inside, whether it's 19 or 20 or 22 degrees, we can maintain that exact temperature, but we can, say, lower the water temperature. So instead of sending 45 degree water through, we might be able to send 40 degree water through and achieve the same result inside. But what this means is that the heat pump isn't working as hard, and that means that the efficiency is higher. It's costing less to produce the same amount of heat, so it's better for you because you're not paying through the nose. So where can radiators be installed? Where shouldn't they be installed, and how much space do you need, or how many radiators do you need? Well, traditionally radiators were installed under windows, as like you can see here. And the reason is, back, you know, let's say 50 years ago or even longer, when the glazing, the windows weren't very good and they would let a lot of heat out and a lot of cold in, the radiators would provide like a thermal shield. So they'd have this sort of curtain of warm air sort of rising naturally in front of them, and it would block out the cold air that was trying to make it into the house. Now, we're pretty lucky here in Australia. We don't get that cold, even though a lot of the windows and houses are not built that well and they are pretty leaky. But we don't have to have them under the windows. We can have them anywhere in the room. But you should have them basically not hidden behind anything. They will still work if you did put something there. You know, you might put a couch in front of it and you might leave a bit of a gap there. It'll still work, but it won't work as well as if it just radiates into the room, this line of sight. And so they still often do end up under windows, like you can see here, because there's generally not furniture underneath the windows. So it's just an easy spot to put them. Where shouldn't you put the radiators? Well, there's not really a spot. Usually the trouble is finding some space where you don't have furniture already, where it's not going to be in the way. So there's not really any places where you shouldn't put them. Often we get asked as well, for big rooms, can we just get away with one radiator? Well, sure, we can put in one massive radiator and it'll do the job, but it won't be as comfortable as if, let's say, we split it up into 2 radiators. Now, generally, say for an average size room, you just need 1 radiator. Maybe even a room double this size, you could get away with 1 radiator. But let's say for most living rooms, and we live in an open plan sort of architectural period, so usually an open plan living, kitchen, dining area might need 2 or maybe even 3 radiators. Take that into consideration. Otherwise, for bedrooms, for normal bedrooms, you can just count on 1 radiator per room. Now, you might be thinking, where am I right now? So I'm at a house in Fremantle in WA, and forgive me if I've already said this. I've been speaking for, I reckon, about half an hour already. So we're in Fremantle in Western Australia. This is a beautiful old Federation home that has been renovated. I believe it was built in 1895. So there's a few of these sort of standard, we call them standard radiators in the rooms. Then there is floor heating in the extension and in the new bathroom, and there's also a towel rail in that new bathroom. And so the beauty of these hydronic systems is that you can combine it with other parts. So you can even, if you wanted to, combine it with your hot water. I don't always recommend it. I only recommend combining it with your hot water if you're really short on space. Otherwise, it's better to just keep it separate. Or you can, say, heat your pool, but again, pros, cons, we can talk about that another time. But you can combine this, say, easily, floor heating, radiators, towel rails, into one system. And so that means that it's great for houses like this, where it's an original sort of Federation home, and then there's an modern extension at the back where we put floor heating. So one of the challenging things with a radiator installation is how to get the pipes from the heat source, let's say the heat pump, to the radiators. Now, one of the better ways is to get it underneath the floor. And here, we were lucky where the whole floor came up because it was being redone, and so there was space to run all the pipes in the insulation and get them to exactly where they needed to go. So that's great. And there's a lot of houses that do have access space underneath. So sure, the installers can get in there, run the insulated pipes, get them to exactly where they need to go, and it's pretty hidden. Another way is we can get them down walls. So in WA, we have the double brick cavity walls. So insulated pipes can be dropped down those, and then they can be turned in and connected to the radiator valves at each radiator. It's a little bit harder where there's a window above, because there's usually a lintel or something there and we have to sort of go around it, but it's possible. And other ways are we go in, or we drop down, say we run the piping in the ceiling, and we drop down, say, in where you might have a linen cupboard or a robe or a walk-in robe, something like that. And so we can drop the pipes in there just discreetly in a corner, and then pop out through the side into a radiator, or the radiator might be backing onto that, so really neatly the pipes connect to that. If a customer really wants radiators, but none of these are an option, other options are we run the piping around the external walls of the house, so they're really well insulated, and sometimes there might be some special capping put over them, or they might be buried in the ground in a watertight sleeve. So that's possible too, to get the pipes to where they need to go. So there are always options on how to get the pipes there. It's just about what's available, the aesthetics, and unfortunately sometimes it's the cost, because it does cost a bit more to dig them in, put them in watertight sleeves, etc. So how long does it take to install hydronic heating? So depending obviously on the amount of radiators, you can sort of average it out on maybe 1 day per radiator. So for a whole house, sometimes it might take 5 to 7 days, or if it's a bigger house, we might have more installers there at once and installing it a bit quickly. You don't have to move out or change anything about what you do. The installers come in the morning, they have their tools, they get the pipes. Usually they hang the radiators first, then they might set up the heat source, and then they need to get the pipes between the two. And so they find the routes where the pipes are going to go, and they clean up after themselves at the end of the day. Sure, they might need to move your couch or your chest of drawers or something to get access, but they'll move it back at the end of the day. And there's not, apart from the inconvenience of having someone there, there's not really any other impact on your house or on your family, on your everyday functioning and living. And that brings me to the next popular question, which is, how much does it cost? So it's depending on the difficulty. Look, it can cost, basically it starts at about $3,500 per radiator panel as the base, and it can go all the way up to $10,000. Now that's for, let's say, fancier radiators, and you might have a really good heat pump system, and it might be a really tricky system, but that's the range. So expect to pay maybe between $3,500 to $5,000 per radiator panel. Supplied, installed, commissioned, warranted, keeping your family warm. And so usually it takes about, if you were to call us tomorrow, depending if it's winter, then you might have left it too late, and it might have to be installed after winter. We'll always try and fit you in, but obviously when there's not a winter rush, unfortunately, it's easier to schedule the radiator installation in. Often we get asked, how much does it cost to run the radiator system? Now, we've spoken about the efficiency. Say, you can have something that's 99% efficient or 450% efficient, let's say. So that's one factor, and that is influenced by the design of the system, the size of the radiators, etc., etc. But the other factor is obviously what you pay for your unit of electricity. Now, 1 unit of gas is cheaper than 1 kilowatt of electricity. So you might pay, 10 cents for gas per kilowatt, but for electricity you might pay 30 cents. Now, the condensing boiler has an efficiency of about 100%. So that means you pay 10 cents per kilowatt for gas, 100% efficiency, so it costs you 10 cents per kilowatt of heat. Now, for the heat pump, and I'm just going to do some rounding here to make the maths a bit easier off the top of my head, you might pay 30 cents for a kilowatt of electricity, and if your heat pump has an efficiency of 500%, then that means that you're paying 6 cents per kilowatt hour of heat that's produced. So it's about 40% cheaper than the gas, right? Now, okay, they're good numbers, but what does that mean for your house? Now, it's hard to exactly gauge because all houses are built differently. You might have a really well insulated built passive house, and you just want, or almost passive house, and want a couple of radiators just to make sure you're 100% comfortable during winter. Or you might have a really leaky house like we see sometimes, and we actually do usually recommend straight away insulate the ceiling first, stop the drafts where you can, and then put the heating system in. But you might be looking at, basically we're looking at anywhere between 50 to 150 watts per square meter of heat. Generally, I would allow for, just for these sort of calculations, you might allow for 70 watts a square meter, and that gives you a rough estimation of what you might require for your house heat-wise. And then you would usually run that for maybe 8 hours a day. But if you want help with that, we've got a spreadsheet. We can easily put those numbers in and show you what the running cost will be, plus minus, sort of in the right ballpark. So I hope I didn't bore you with all of my physics, and I can see sometimes people's eyes glaze over, but hopefully you found this helpful and informative. And if you do want help with putting a radiator heating system in your house, whether it's an existing house or you're doing a renovation and you'd like to incorporate it with some floor heating in the new part of the house, please do give us a call at Euroheat. We'd be happy to talk through the options, let you know what's the most economical or best option for your particular project, and give you a price and talk you through all of the steps to make sure that you and your family and your pets are comfortable this winter.